All right, so in data part 2, we're going to calculate the mass of the water measured by the balance. And this is what we call massing by difference, and it could show up on the SOL. Massing by difference. When we mass by difference, we take the mass of a container and then put our irregular object in it, and then take the mass of the combined mass of all the substances, and then subtract. Okay? So, in other words, we're going to take the mass of the cylinder and the water, because you can't just pour the water out on the balance. Make no sense, right? So we've got to have the mass of the cylinder and the mass of the cylinder and the water. So I need another group. Another group. Give me your numbers. What did you get for the mass of the cylinder and the water? 78.3 milliliters. Good. Notice we went to the first decimal. The reason we went to the first decimal, anytime we use the graduated cylinder, we know that the graduated cylinder is marked to the ones place. And so we want all the certain digits by the instrument and then estimate the next digit. Okay? So since the instrument goes to the ones place, we should have a decimal place. Okay? So 78.3 milliliters minus, what is the mass of just the cylinder without the water? That group gave me that number. Is it you, Sue?
Yeah, I'm going to be wrong.
Okay, come back, give me the right one. Anybody, this is data table 2. Any group. Data table 2, what did you get for the mass of the cylinder and the water?
I had 88.0.
88.0, okay. All right, that would be milliliters. All right, what did you get for the mass of just the cylinder?
15.0.
That's grams, isn't it? I'm sorry.
Yeah.
Okay. 15 what?
15.0.
Okay, now, actually we have messed up here a little bit because with the balance, it's different than a graduated cylinder. I forgot we were talking about mass. The balance read to the first decimal, so you were supposed to estimate the second decimal. So we're going to put in an extra 0 here. Okay? All right, so what do we get for the mass of the water here? We got, what'd you get, Jesse? 70.
We didn't get that. Oh, never mind. 73.0.
Okay. All right. So that is finding the mass of the water. We're going to go ahead and keep our video going and look at how we're going to do that to calculate the density of the water. Okay? So we've got the mass here of the water. Okay? We calculated the volume of the cylinder, or the volume of the water we used. How much was the volume of the water that you guys used in part 2, Jesse?
79.1.
79.1 milliliters. Okay, so then the density formula, which is good because this is what will be covered in chapter 3, is the mass of the water that we measured divided by the volume. And so the mass, in which we got by massing by difference, the original container without the water, pour the water in, combine mass, subtract. Massing by difference, we got 73 grams, 73.00 grams. Okay, and then we're going to divide it by the density, the volume, 79.1 milliliters, the first decimal. So this will be the density of the water, 22 degrees, that this group got. Did you calculate that?
We didn't get the temperature. But we got that.
What do you get for the density?
0.9.
0.9. We'll say 0.90. We should go to the first, actually 0.900 actually is what we need, and I'll explain that more later in class. Okay, so we have calculated the density of the water. Now, the last step for part 2 is to calculate the percent error for the water. Now, I gave you the theoretical or the accepted density of the water is 0.997. So, the accepted value or the right value is 0.997 for the density. So now, how do we find the percent error? Does anybody want to lead us through the percent error here? Percent error would be what? Somebody tell me where the numbers go. I've got two density values, 0.900, 0.997. What am I do to find the percent error?
You subtract 0.900 minus 0.997 divided by 0.997.
Divide by 0.997. How did you know to divide by 0.997? Because it is the
Accepted value
accepted value.
times 100.
Okay. What do we get here for the percent error for this group only?
We didn't get that far.
Will somebody calculate their phones, get your phones or whatever? If you want to put your phones up. Taylor, would you calculate that, please?
Yeah.
0.900 minus 0.997 divided by 0.997 times 100.
If I did it right, I got negative 9.7.
Okay, couldn't be negative, because we got absolute values.
I don't think I did.
0.900 minus 0.997 will make it positive, probably will be 9.7.
Good.
You're supposed to, in absolute values, it's a good thing that, in absolute values, whatever this difference comes out to be, we make it positive.
That's an absolute value.
I think it's 9.7.
It is.
Okay, Jesse.